Example 4 asks us to find the angle x given these different ratios. So here I've been given tan x equals 1.50. So if I go back to my big idea, if I want to find the angle from the ratio, I'm going in this direction here. So I need to use arctan. So I need to rewrite this using arctan. So I'm going to write it like this. Arctan of 1.50 is equal to the angle x. And typing it into my calculator, I get angle x is equal to 56.31 degrees. 309, so I'm going to round that to 31 degrees. And what that tells me is if I have an opposite to adjacent ratio of 1.5 or a slope of 1.5, the angle that's made is 56.31 degrees. So same thing here. I've been given the ratio. I need to find the angle. So instead of using cosine function, I'm going to use the inverse cosine function, where my input is going to be my ratio, and the output is going to be my angle. So when I type that into my calculator, I get angle x is equal to 84.83, so 836, I'm going to round that to 84 degrees. For the sine, same thing. I've been given the ratio. I need to find the angle x. I need to use an inverse function. The input is going to be my ratio of 0.555. So that means that the opposite side is about 55% the length of the hypotenuse. My calculator tells me the angle that goes with that shape is 33.71 degrees. Okay, so that's my angle x. So my angle is 33.71 degrees. So for these problems, this is where we're going to use our calculator. We've been given, in this case, shape. We need to figure out angles. Well, we need to use our calculator to do that. We have the description with shape. We need to give the same description with an angle. So I'm going to start with angle A. So I know that I have an opposite hypotenuse side. Okay, SOHCAHTOA tells me that's SO or sine. So I'm going to write this as sine of angle A is equal to the opposite over hypotenuse ratio. Now the problem is I don't want the ratio, I want to solve for the angle. So I need to use an inverse. So I'm going to write this as inverse sine. The ratio is 3 over 4. And that should give me my angle A. Okay, so if I get my angle A, so inverse sine of 3 divided by 4, it gives me 48.59 degrees. So what that tells me is that angle A is 48.59 degrees. I can find angle B from subtracting from 90 degrees because they are complementary angles. And so 41.41 degrees is going to be angle B. So I've got all three angles now. I just need to find the side length. Well, the side length, I don't need angles to do this. I can use Pythagoras. So I'm just going to move this out of the way a little bit here. So if I want to find angle A, side length A, I can just use Pythagoras. So I'm going to say that 4 squared is equal to 3 squared plus A squared. So that's one of the shorter sides. So we're going to subtract 16 minus 9. So A squared equals 7. And I'm going to leave my answer in the root form. Okay, so A is approximately it is exactly root 7, which is approximately 2 point, well, let's work that out with our calculator. Root 7 is 2.65. So I've solved that triangle. Okay, And this one actually only asks us to solve for angle A, doesn't it? So we're just gonna, for the next one, I'm just gonna solve for angle A. For the this problem here, down here, we're gonna be solving all the sides. Okay, so this problem, we're just solving for angle A. So to find angle A, I'm gonna use opposite and adjacent. Okay, so opposite, adjacent, SOHCAHTOA, that's tan. So I'm going to write this as tan of angle A is equal to opposite over adjacent. That is a ratio. I want angle. I need to use the inverse tan for this problem. So giving the shape of 30 over 22 as my slope, that will give me, my calculator will figure out angle A for me. So inverse tan of 30 divided by 22 gives me 53.746, so 75 degrees. So angle A is 53.75 degrees. And this shape looks about right, so that angle looks about right as well. Okay, we can't really count on the diagrams being drawn accurately all the time. In this case, it looks like it's reasonable.